Today's lesson is on graphing linear inequalities from standard form. If you haven't already printed off the video guide, go ahead and pause the video, print the video guide, and then come back and do the examples with me. Now, our previous lesson was on linear inequalities, but we had the linear inequalities in slope-intercept form. Now we're given the inequalities in standard form. So it's very similar. We still have to remember solid and dashed lines and shading the grass or the sky. But before we can actually graph it, we have to solve it, just like an equation, okay? If we had a linear equation that was in standard form, we would have to solve for y, and then we could actually graph. So that's what we're gonna do with our problems today. So let's go ahead and start with number 1. We have x minus 5y is greater than or equal to 15. So I'm going to put my line through the inequality sign and go ahead and start solving. Remember, always get rid of your x first. Now this x does not have a number in front, so I'm going to go ahead and put the 1 there so I don't forget about it. So to cancel out a positive 1x, we must do the opposite, which is subtract 1x. So minus 1x or negative 1x on both sides. 1 minus 1 is 0, those cancel. The negative 5y comes straight down. My inequality comes down, greater than or equal to. Now remember, standard form, we want it in slope-intercept form, which is y equals mx plus b. The x term must come first. So my negative 1x must come first. After that, we have our positive 15, so we put plus 15. From here, we need to get rid of the negative 5. Now remember, when a number and a letter are right next to each other, it means multiplication. So the opposite would be to divide. So I need to divide everything by negative 5. Make sure you divide everything, all 3 terms. This cancels. I get y. Now here's the trick. The one difference from solving inequalities and solving equations. If you divide everything by a negative, which is what we did, we divided everything by negative 5, you must flip the inequality sign. Instead of greater than or equal to, we now have less than or equal to. Make sure you do that. Anytime you divide everything by a negative, you must flip the inequality sign. So instead of greater than or equal to, we now have less than or equal to. And then the rest of it, you solve it just like normal. So negative 1 over negative 5. I can't simplify the numbers, but I can simplify the signs. Negative over negative is a positive, so I get positive 1/5 x. And positive 15 divided by negative 3, or negative 5, excuse me, is negative 3. So minus 3. Now that it's in slope-intercept form, I can graph it, okay? So my slope for this problem is positive 1/5. My y-intercept is negative 3. Remember, when you're graphing, graph the y-intercept first, negative 3. So the y-axis is always your vertical axis. So negative 3 means we go down 1, 2, 3 places. Put a point. After that, we can go ahead and do our slope. Our slope is positive 1/5, so that means my rise is positive 1, so I go up 1. My run is positive 5, so I go to the right 5 places. Put my first point. We can also do the opposite. Instead of positive 1, we'll make it negative. Instead of positive 5, we'll make it negative. Negative 1 over negative 5. Go back to your y-intercept. Negative 1 means down 1. Negative 5 means to the left. 1, 2, 3, 4, 5 places. Now we have to determine if this is going to be a solid or dashed line. Remember, the equal to bar is what lets you know if it's solid or dashed. Equal to bar is there, it's going to be solid, okay? If there wasn't an equal to bar, then it would be dashed. But this is going to be a solid line because of the equal to bar. So I'm going to connect my points with a solid line, as straight as I can make it. Remember, we put arrows at the end to show that it's going on forever. okay? Now this is our line, but we're not quite finished yet. For inequalities, there is shading. Now, because we had to flip the inequality sign, because we divided by a negative, this is now a less than sign, okay? So remember, if I have my little man standing on this line, if it's eating the y, if it's greater than, I would shade the sky. Eating the y, shade the sky. If it's eating the equation, we shade the grass. So this is eating the equation, so that means I shade below the line. I shade the grass. So shade down here. This is the smaller than area, okay? So shade the grass. And that would be our graph for problem number 1. For problem number 2, our inequality is 7x plus y is less than or equal to -3. Again, this is in standard form, not slope-intercept form, so we must solve it before we can graph it. So I'm going to draw my line through the inequality. Always cancel out the x term first. This is a positive 7x, so to cancel it, we will subtract 7x from both sides. Minus 7x here, minus 7x here. They cancel. This is a positive y, so I can just write y. Keep the inequality sign the same. Remember, you only flip it when you divide by a negative. Only flip it when you divide by a negative. The x term comes first, so I have negative 7x, and then the -3, so that's minus 3. Now, at this point, you'll notice y is already by itself. I don't need to divide by anything. There is no number in front of y, so I don't need to divide the equation by any numbers. So I'm finished solving. Now I can go ahead and start graphing. So looking at our inequality, my slope is -7. Remember, to make it a fraction, you give it a denominator of +1. So this is -7 over +1. The y-intercept is going to be -3 because it's a -3. Always graph your y-intercept first. So to graph -3 on the y-axis, you must go down 1, 2, 3 places. There's our first point. All right. After that, my slope tells me that the rise is a -7, the run is a +1. Well, if my rise is -7, that means I'm supposed to go down 7, but I don't have enough room. That's okay, we can still graph it. It just means we have to change or do the opposite of our slope. So instead of -7, make it +7. Instead of +1, make it -1. Now that my rise is a +7, I can do that. I can go up 7 places. So 1, 2, 3, 4, 5, 6, 7. Always start at your y-intercept. After that, the run is -1. -1 for the run means to the left 1 place. So I put my point right here. Okay. After that, you need to check your inequality sign to determine if this is supposed to be a solid line or a dashed line. So looking at our inequality sign, we do have that equal to bar. Anytime you have the equal to bar, it means your line will be solid. So I'm going to go ahead and connect my 2 points with a solid line, putting arrows at the end, like this. And now we just need to shade. So my person, if they were standing on this very steep line, would be right about here, otherwise they'd be hanging upside down. My inequality is eating the equation, not eating the y, it's eating the equation. So that means it's less than. Less than means we shade the grass, right? Greater than is eating the y, shade the sky. Less than is eating the equation, we shade the grass. So the grass would be below his feet, so that's this side of our line. So all of this gets shaded in. All of these, remember, the shaded area means that all of these points, any point that you find in the shaded area, whatever you pick, all of these points are answers. Okay, every single one. I'm not going to shade them all in, but you get the idea. Any point in this shaded area is a solution for the inequality, which is why you must have the shading done for this inequality to be graphed correctly. Okay, so this would be your graph for number 2. For problem number 3, our inequality is 3x minus y is less than negative 3. This is not in slope-intercept form, so we must solve it first. So drawing my line through the inequality, I must cancel out the x term first. This is a positive 3x, so to cancel it, I will subtract 3x from both sides. They cancel. This is a negative y. You must keep the negative sign with the y. The less than sign stays the same because I did not divide by a negative. Make sure you put the x term first. So negative 3x comes first, and then the minus 3. Now, y is not by itself. There is a negative sign in front of it, okay, which means it is not alone. I'm going to go ahead and put the 1 in front of the y so that I remember, oh, okay, I need to divide by a negative 1 to cancel out that negative sign. So you must divide everything by negative 1, all 3 terms. This cancels, our y just comes down. Now, you'll notice I divided everything by negative 1, which means I need to flip the inequality sign. So instead of less than, it becomes greater than. Only when all 3 of the bottom numbers are negative do you flip the inequality sign, okay? So in this case, I must flip it because all 3 of these are negative. Now, negative 3 divided by negative 1 is positive 3x. Negative 3 divided by negative 1 is positive 3. So my slope for this inequality is 3 over 1. Make sure your slope is a fraction. Any whole number is a fraction with a denominator of positive 1. Your y-intercept is 3. So graph the y-intercept first. It's a positive 3, so that means we go up 1, 2, 3 places. My slope is 3 over 1, which means I go up 3 because it's positive 3. 1, 2, 3. And then the run is a positive 1, so that's to the right, 1. And I run out of room, okay? But there's still more points that I can graph. I just have to do the opposite. Instead of positive 3 and positive 1, I'm going to make it negative 3 and negative 1. So I start at the y-intercept again, and negative 3 means I go down 3, 1, 2, 3, and a run of negative 1 means go to the left 1. And I can do it again, so let's go ahead. 1, 2, 3, down 3, left 1. And again, down 3, left 1. Okay. And that's as far as we can go. Now, to determine either if it's going to be a solid or a dashed line, look at your inequality sign. There is no equal to bar here. That means our line must be dashed. So I'm still going to connect my points, but it's going to be with a dashed line, not a solid line this time. Must be dashed, like that. So you got to have holes in your line. And then last but not least, we need to shade. This is a greater than symbol, all right, because we had to flip the inequality sign because we divided by negative. So if my guy is standing on this line right here, greater than is eating the y, yes, eating the y, so we shade the sky. Eating the y, shade the sky. So sky would be up above his head, so that's all of this space needs to be shaded in. All of these points are solutions, so we're shading it in all over, okay? And that's our graph for number 3. At this point, go ahead and pause the video. I'd like you to work on number 4 on your own, and then come back to the video and check your work. For problem number 4, the inequality was 7x plus 2y is greater than negative 6. You needed to solve the inequality, so get y by itself. All right, so I subtracted 7x. After that, make sure you put 7x first and then the minus 6. But after I did that, I divided everything by a positive 2. When you divide by a positive, you do not flip the inequality sign, Okay, so notice I kept my inequality sign the same. Only when you divide everything by a negative. All three of these are positive. It doesn't matter that these top ones are negative because this top one is positive as well. All three of these are positive, so that means I do not flip the inequality sign. It stays the same. Okay, only flip it when the bottom ones are all negative. So that means my inequality is y is greater than -7/2 x minus 3. So to graph that, I did my y-intercept of -3, so I went down 3. Now my slope was -7 over +2, but I can't go down 7. I don't have enough room. So I went ahead and changed it. I did the opposite. So instead of -7, I did +7. Instead of +2, I did -2, which means you go up 7 to the left 2 and put your point. From there, I looked at my inequality and saw that there was no equal to bar, which means I needed a dashed line. So this is a dashed line. I also saw that this is a greater than symbol. It's eating the y, okay? So if it's eating the y, you shade the sky. So my little man's right here. The sky is above his head. So that's all this space right here needs to be shaded. And that ends our lesson on graphing linear inequalities from standard form.